Today on the Farm Finance Show, we'll be talking about simulating cotton harvesting, a potential use case. Well, hello and welcome back to this series of how to use this cotton simulation model. This is really the fourth video in the series. The first three were explaining about how the simulation tool actually works, so I would encourage anyone viewing this video who hasn't done so to view those first three videos. That will help with explaining what happens. But this is a video about explaining actually how you might use that, and it's a potential use case that has some real potential numbers and how we might actually design a cotton harvesting bot to match what the deer picker can do. So let's look at what I've changed some of the basic inputs to look at what might be more realistic situation. And if we click on the common inputs, we can see what I've done. So before, basically, I had a longer harvest window. What I'm assuming now is that we have about a 60-day window and that the cotton bolls will fully ripen during that time frame. And we want to try to get our cotton harvested within that 60-day time frame if we can. So I basically have shortened up this boll opening CDF to make everything fully open by the 60-day time frame. I kind of left the yield and the price distribution, how they might change if something is lost, if there's a rainfall event. That's what it was before. I'm assuming kind of a wetter climate. Maybe this would be like a Mississippi harvest environment where there's a higher chance of rain. I put the probability of rain for about 10%. That may be a bit high, but I'm just assuming a wetter climate that we have a 10% chance of having rain on any given day. And then there's a 5% chance of a hurricane actually occurring during this harvest season. And with that 10% chance of rain, here's what the distribution looks like if there is a rainfall. So again, this is how I just kind of shortened it up for what the model kind of defaults to when you first open it up. As far as the bot inputs is concerned, I'm assuming we're going to start off with 5 bots to start with. Again, these are going to be 1-row bots. The speed of the bot as it goes down the row is going to be 2 miles per hour. And again, a bot is allowed to go over acres as many times as it needs. We're just going to start picking cotton as it starts to ripen up based on that distribution on the previous page. And then it will keep going until things are done or until we run out of time. Again, assuming an 8-hour per day harvest window and assuming the lifespan of the bot is going to be 7 years. Here's my defaults going into the model. We're assuming that you can build a bot for $40,000. I don't really have any cost to operate the bot per hour right now, although there'll probably be an electrical charge or something similar to power the bot. And here's my repair and maintenance percent as the percent of new. This is kind of based on what some of the ag engineers formulas have. Looking at my percent salvage value as a percent new. Again, that's based on ag engineering formulas. A 1-row harvest machine, 85% field efficiency, and the probability of a breakdown per day is at 5%. And then looking at the deer inputs for the hardboard module builder, basically assuming a $1 million machine. These are the repair factors for that type of machine. A 590 horsepower motor, 19-foot harvest width, 80% field efficiency. There's a 3% chance of a breakdown on any given day. $3.50 diesel price, and then a picker labor cost of $15 per hour. And then I'm assuming we're going to start harvesting when 70% of the bulls are open. Then we'll go ahead and start desiccating the fields and harvesting at that point in time. All right, well, these numbers were calculated. This is based on these numbers here. You get basically annual machine hours. This is 240 hours. Fuel consumption of 26 gallons, fuel cost, salvage value, so on and so forth. Again, based on all formulas, based on our numbers from this point in time. All right, let's go to the output section and look at what our outputs might be. So we'll go ahead and run this. And you can see what happens here. So with the bots, we actually have a lot of cotton that's we don't get harvested because we have a loss of open cotton bolls right here, whereas the deer machine did better than this. And you can see what's happening here. So the deer machine does a fairly good job in that window, the 60-day window, of giving everything harvested. Again, we had to wait a little bit longer to get harvested started because we had to wait for most of the bulls to start opening. But as you can see what happens, once we do get that deer machine in the field and running, it goes down pretty quickly here. So by the time we get 60 days, we still have, a fair amount left, but not near as much as what the bot machine system is doing. We just don't have enough bots, or they're not going fast enough to get things down, and that greatly affects the cost per acre because we are leaving so much cotton in the field at that point in time. So you can see what our cost is, as opposed to the $116 machine cost is only $20, but we're leaving so much cotton in the field, and even with the Deere machine, we're leaving quite a bit of cotton in the field. So let's kind of go back then and maybe change some of the common inputs to what we're looking at. And we can look at, let's maybe make our harvest window to be up to maybe 80 days. Because we're not getting it done with the Deere machine even at that point in time. So let's make the potential harvest window up to 80 days. We won't change anything with how the cotton bolts open. We'll leave that what it was. But I think we're going to have to go ahead and add a few more bots. So right now we're at 5. Let me bump that up to maybe 8. And let's just go see how this scenario runs like this. So we'll go ahead and run it again. So now you can see with an 80-day window, we do manage to get all of our cotton picked with the Deere machine. You can see after about, probably about 70 days or so, everything is harvested, which means we don't lose too much on the quality and quantity side like we did before. So just the machine cost to operate that many acres is $131. We still lose about $23 again through the rainfall events damaging cotton, both the quantity and quality. I don't think we had any hurricanes show up, but we did have quite a few rainfall dates, as you see here. So that's affecting the quality and quantity for the Deere machine. But even with that, even though it's only costing us $32 per acre to operate this, we still have quite a substantial loss, quality and quantity loss with the cotton bots. That makes the cost prohibitive here. So we're going to have to do something to adjust this. Either add more bots, or let's try bumping up the speed. So right now we're going at 2 miles per hour. Let's bump that up to 3 miles per hour and see what happens. And let's go back and rerun our scenario again. All right, well that's helping. We're still leaving out quite a bit of cotton in the field, though, as you can see here. By the fact we're not getting this blue line down to the baseline here. So it improves the cost, but we're still not where we should be. So let's go ahead and change some more inputs. I think we're going to need more bots, so let's bump our bots up to maybe 10. And let's go back and try to rerun this again. Okay, we're getting there now. We're down to this amount of loss, which works out to be about $266, which is still pretty substantial. But you can see now we're actually, with that number of bots and that speed, we're getting about a 4.5 picking multiple, meaning each bot is going over the field 4.5 times. So and you can see with just the machine cost, our machine, just to run those machines at 40,000 pieces, is really not that expensive. It turns out to be about $41 per acre versus the $131. It's this loss here in quality and quantity because we're not getting all of our cotton picked at this rate and time. So we really need to do something to add more speed. So let me put my bots up to 12 and try rerunning another time. All right, so we're getting there. You can see the cost is not too bad. But again, we're still leaving probably more cotton in the field than what we wanted to. So this is the way I would suggest using this tool, is just to do a bunch of what ifs and play around with this and work through scenarios until you can kind of get the amount of cotton of leaving down to 0 like we are with the Deere picker, whether that involves going faster, adding more bots, or whatever. It's going to take more than that to avoid this big loss of cotton that we're seeing right now. So I'll stop this video right here.